let's play with some fancier applications of the power rule. How about the integral of square root of x? Well, square root is a power, right? So we can rewrite this as x to the 1/2 dx, or we could write it as x to the 0.5 dx. Either way is fine. And then if I apply the power rule to this, what do? I do x to the 1/2 plus 1. And what is 1/2 plus 1? It's whatever we're going to write there. So 1/2 plus 1 is 3/2. So I'd write 1 over 3/2, x to the 3/2. Or from this point of view, you could say it's x to the 1.5, 1 over 1.5. And same here. Of course, we should be doing our plus c. All right. Now, some people like to say, oh, well, 1 over 3/2, I can simplify that and leave it and make it 2/3. But I say don't bother, because what if this wasn't x to the 1/2? What if this was x to the 0.4? Then you get a 1 over 1.4, and do you want to simplify that? Probably not. I would say, unless it's really important, and especially if your like Calc 2 professor expects you to, then kind of simplify this to 2/3. But it's okay with me to not simplify. I think a lot of times when people get in the habit of simplifying, they end up kind of making a second version of the power rule for themselves, which is still true, but it's like if you put the fraction here, then you put the flipped fraction over here, and you just don't want extra rules cluttering up your memory when you can just have one rule that just works. It gives something that's maybe not the most elegant, but it's at least easily traceable, so I encourage that. How about the integral of x to the -4th dx? Take a sec to write out what that should be with the power rule. So that would be integral of, we want to do the integral, we don't want to write it again. X to the -4th plus 1, 1 over -4th plus 1. And here you should simplify, right? That's easy enough to simplify. Get -3, x to the -3. So it feels weird because we're used to, when we're integrating, integral of x squared is something or other x cubed. Integral of x to the 10 is something or other x to the 11th. Now here it feels like the power went down from 4 to 3, but it really went up from -4 to -3. So that's another thing we got to practice. Where could this have come from? Where might you see this in some other context? Well, you could have seen it as 1 over x to the 4th, integral of 1 over x to the 4th. So then you would write that as x to the -4, integral of x to the -4, and then do stuff on that. All right, let's combine these concepts. How about the integral of 1 over root x? So go ahead and apply what you know to that. All right, welcome back. So hopefully you rewrote it as x to the -1/2 dx. And then the integral of that would be x to the -1/2 plus 1. 1 over -1/2 plus 1. Which, what is -1/2 plus 1? Positive half. So it would be 1 over 0.5 x to the 0.5. And again, you could simplify this, but I think unless there's a really clear reason that you should, it's fine with me if you don't. All right, how about integral of 1 over x? That's fun, right? So go ahead and apply the power rule, see what you get. Well, you probably said this is rewriting it as x to the -1. And what does the power rule give you? X to the -1 plus 1, 1 over -1 plus 1, which would be 1 over 0 x to the 0. Does that look safe? No, that looks like a whole world of hurt. You're going to be dividing by 0. So give that a big oops. And anyway, if this was the antiderivative, if x to the 0 was, even ignoring the 1 over 0, that's just a constant. What's the derivative of a constant to get back to here? It's not 1 over x. So it's like failing us two ways. So we need something else. Power rule isn't going to work here. What does work? Well, what function, when I take its derivative, gives me 1 over x? So let's just recall. The derivative of natural log of x is 1 over x. So what can we say? The integral of 1 over x dx is natural log of x plus c. And that's true. Sometimes we get even fancier because 1 over x works for positive and negative values, even though log doesn't work for positive and negative values, only for positive. So it turns out you can make it all work by saying log of absolute value of x plus c. And that's actually one of the homework problems to explore why that works. So this is true when x is positive. And if x is positive or negative, then this is what we write.